So for the final lecture of Chapter 1, I wanted to talk a little bit about unit systems and conversions. At least I hope it's the final lecture. If not, I'm going to look down. But I'm not going back and re-recording this just for that small error. I'll make actual important errors over the course of the semester, so you'll have to forgive me for that one. So unit systems, we're going to work with two in this class. We're going to work with the metric or SI system along with the empirical system or the U.S. customary system or the foot-pound second system. It gets three different terms in this text because it is so special. So as scientists or engineers, you're tempted to say, oh, we'll always be in SI units because they have that nice property where you can scale them to fit your need by attaching prefixes or orders of magnitude. However, particularly on the mechanical and civil sides, we just have a norm in a lot of Western countries of describing things, and we don't need to get an argument of is it a lot or not. Certainly here in the U.S., if you go and look at different screw sizes or threads or these sorts of things, it's very common to see specifications of physical objects in the FPS system, inches, feet, these sorts of things. So in terms of the basic mechanical units that we described, you can basically define the units of 3 out of the 4, but the fourth has to be derived because of that Newton's second law type relationship. So what are the fundamental units in the two system? Well, what are just the fundamental quantities, right? We have to be able to describe length, time, mass, and force. So in the SI system, of course, length is going to be measured in meters, time in seconds, mass in kilograms, and then we will actually define what a Newton of force is by Newton's second law. If F equals ma, a Newton has to be the product of mass times acceleration. Remember, mass is in kilograms here. I was pointing at meters and length, kilograms, and acceleration, since it's the second derivative of position, will be in units of meters per second, which is just meters per second squared. So Newton in this case is a derived unit. On the FPS side of things, we measure length in the standard unit of foot, time, of course, still in seconds. Force is measured in pounds, right? When we actually talk about our weight, as we did in the previous lecture, we're familiar with measuring that force in pounds. So mass is actually going to be defined in this case, the defined unit in this case, and it's going to be in the FPS system measured in slugs. And if you think about solving for m, it's just going to be F divided F. So remember, F equals ma, so m will be F divided by a. So that's why it's pounds divided by the units of acceleration, which flips and actually makes this second squared in the numerator and feet in the denominator. In terms of converting between the two, if you ever need to do it, just know that these conversion factors exist, and you can do dimensional analysis in order to make the conversion, which is what I'm going to show you here. If you have a quantity 2 kilometers per hour and you want to convert it to meters per second, I can just incrementally ask myself, what do I need to multiply by in terms of conversion factors to get rid of kilometers and go to meters? Well, to get rid of kilometers and go to meters, that's going to be really easy, right? Because a kilometer by definition is what? It's 1,000 meters. So if I multiply by 1,000 meters divided by 1 kilometer, these quantities in the numerator and denominator, they're the same thing. So multiplying by them doesn't actually change the underlying value of this quantity. I can cancel the units just like I would cancel common factors on the diagonal. The kilometers go away. So 2 kilometers per hour is equivalent to 2,000 meters per hour. But I don't want hours. I want to get rid of that as well, and I want to get seconds. Well, how am I going to go about getting rid of the hours? Well, the natural first step is just to convert it to minutes. 1 hour is 60 minutes. However, I need to go all the way to seconds, so I'm going to have an additional factor of 60, which means that 2,000 that I scaled will be divided by 60 squared, and if you multiply that out, you'll get 0.556 meters per second. Why 3? Well, as we'll discuss in the next video, I thought we were done. It often turns out that for these types of for the problems in our text, we'll be asked to report answers to 3 significant figures, and we'll talk about that in the next video.